Uh,
Yeah.
okay.
Yeah.
Sorry for hijacking the meeting there, but okay.
Yeah, sorry. Yeah, go ahead, Sandeep.
But I
Yeah,
think,
yeah,
Liam, we should follow the observability track, because I think personally, if you look, I mean, one of the comments that I made is, what's the point of building a gRPC service if you can get access to the API server direct, right?
Yeah. Yeah.
So there is lots of things to. I personally believe that the approach that we have for the Edge Watcher is the right one.
all right.
Okay.
But okay, that's a different conversation.
Yeah. So welcome everyone. This is SDK meeting, SDK meeting, and just started the recording. So we already have some agendas listed down by a few of us in Slack channels. Let me try to share the screen, and based on that, we can just get started.
I think Wim can go first. He listed.
Yeah. So there are two documents. One is what you have shared, Stephen, about the primarily POC proposal, and what Wim has suggested is config referencing, which I think we want to discuss. So, as you said, Wim can go first and discuss about this config ref NF deployment CRDs. Wim.
You take the slides, or do you want me to share the screen?
Yeah, you can share the screen and share the slide. That will be better. I'll stop sharing if you want.
All right. I also prepared some slides for CapGen, but I don't know whether we have time to discuss it. So I did not send them yet, but I just finished them. You see my screen?
Yeah, I can see.
Yeah, so I started to do some let's say work and look at this, right? So this is basically a discussion point. And I to give some, and maybe there is other ideas around it. I think if you look to the operator on the workload cluster that we have to build, right? So we have this concept of config ref. So I put an example here on the right hand side. Isn't it something that we use, for example, in R1, right? So this is the SMF deployment. So I call it NF deployment, but there is an SMF, there is an UPF, and there is an AMF, but they are all using the same CRD at the back. So we have this concept of config refs. So you see an example on the right hand side. So on the right hand side in blue. So we have a config ref is basically it's a resource. So it's basically API version. So API, so group version kind namespace name. And so there is an example here, right? And so the way we at the moment config refs work, and I believe this is the approach that we have suggested to use also for vendor extensions and stuff like that, right? In R2. So so the object at the moment, how it's designed, is we can use it with any API version kind namespace name, right? And so that means that so basically you can reference any CRD or CR actually, so a CR through that, right? Now a CR, so if you look at this, a CR that needs to be then within the scope of a CRD needs to be installed in the work on the cluster that the operator is consuming, right? And what you see, or at least my experience is that if you really go to a production environment, is that you see that CRDs are not something that you can install for free. So there will, I think there was a presentation from Verizon at some point that basically they said, okay, CRDs will be installed by another team than the app itself. And so, so first of all, they are cluster scoped. You have a dependency that your operator will, if you do watches or anything you use in the controller runtime, if you reference the CRD and it's not there, it will throw in errors, right? So it should be installed before the operator runs, right? And the other thing that people, it's not a very commonly known thing, but and now the limitation has changed, but it's still, so there is 400 CRD. If you go above 400 CRDs in the cluster, so the client starts throttling, So there is, so you get really performance things. Of course, 400 is already, it's a reasonably large number, but it's not very large, right? So that's just background, right? So now from my perspective is that if you look to the operator behavior that runs on the workload cluster, one of the things that it should do, I think, very early in the pipeline of the thing is that it should check whether the CRs that are referenced, that they actually are available in the cluster, right? So that they are actually there, because they give you additional information to basically render the rest of the resource somehow, right? So that means that someone needs to, so if you basically take any CRD or that anyone can reference, it means that you have to have somehow some logic and that basically does that dependency management, right? So, and also what you see is that if you use the structured client of the controller runtime, you have to have that schema in your code, basically. Now, so because you will actually get failures on the controller runtime if you don't. So there is, there is an alternative approach to using this whole option, which is something that we are using in R1, and we used it to do the dependency management. So rather than, so what we basically did is we create, you can say it a meta CRD, but we created basically an encapsulation of any schema that someone has. And so the example of code is on the right-hand side. So there is this concept in the API server, which is the raw extension. So you can reference an object with a schema and stuff like that, but that you don't have to basically reference that necessarily in the API server itself. I think I know, I saw also our radio guys, for example, are using this approach because one thing that I forgot to mention is that there is size limitations of CRD. So if you use, for example, a Yang file or a Yang schema, depending on how large it is, the chances are that you run out of the space in a CRD. So I've seen various examples that it's basically impossible to actually take a Yang file and reference that.
So I will mention that a quick mention that because we're supporting a list of extensions, we actually kind of indirectly have a solution to this because you can actually separate it into multiple CRDs, right? If it's too big.
But you have to split. No, you have to split your Yang file, right? Nobody will do that.
Yeah, but we can actually create an API that automatically does that. So when you pack it, we can actually check if it's too big. And if it's too big, it could be divided into two. And there could be an API that automatically combines them and gives you back the data in the SDK. Just putting it as an option.
You don't even, with what I'm proposing, you don't even have to do that. Because the schema of the Yang doesn't even exist in the API server. It just exists in the code. And you can do basically anything. So you don't even, so basically what I'm proposing here, you can do today without any code. So this is an extension that you have in the API server, which, you don't have to do any of the trouble you mentioned. I think it has, I mean, you don't have to do any code because you cannot render your Yang schema if it's split. It will not render. So let me first finish. So first, what we can do, which is basically what we did for R1, is we basically use this raw extension. That means that you actually can reference any schema there without actually registering in the API server. And the advantage of that is that we kind of create like a meta CRD, if you will, that is basically an encapsulation for a more specific schema, right? So the advantage with that is that you don't need to, so basically you have to install one CRD, or depending if you use multiple flavors to do encapsulation. But in theory, you could basically do it with one. So that means that your dependency management becomes simpler because you basically have that just one just one CRD, and it also allows so it will scale way better and stuff like that, right? So the discussion here is that is whether we have a preference or not, and yeah. Do we want to be flexible for anything, or do we want to basically direct people into, or at least the nephew part, into a specific direction? So that's basically what why I wanted to discuss it, because it also, I will present it tomorrow also in SIG Automation, because it's not necessarily linked to the SDK, because we want to build these vendor agnostic extensions. And this is also relevant in that context, but it's also relevant in the SDK. So that's why I wanted to discuss it. So I think, Tal, what you're proposing is of course you can split it, but that means you have to write code, you have to do specific things, which in my view is a bit of it doesn't serve a real purpose if you can do it without that. That's my view.
I do understand. Yeah, I think your approach is absolutely cool, but it does have certain cons, right? The con is that it is very opaque, right? So yeah, you can generate the data in your code. I guess, like what you said, do we want to be flexible? And I'm all for flexibility. I do think it's not too hard, actually. Already in my mind, I can see the code to create an API in our SDK that automatically packs and unpacks and divides it into several. So there are cons to the raw approach, right? There are various tools that won't be able to read it, and if you use kubectl to take it out, there are cons to that approach, right? Yeah.
No, I mean, basically, see, the way it works is you basically, it's the input. So basically it's relevant for the source, right? But typically, I mean, if you look to our system in the management server, we don't interpret. So the whole idea of the config ref is that we are not parsing it at all, right? So in other words, it's a cut through thing. And of course, the operator itself needs to understand it, but you typically have that knowledge because the receiver is expecting it.
Sure, but let's say you want to do some specialization with a kept function that actually updates or changes that configuration somehow.
Yes,
so it's not necessarily opaque, right? You sometimes do want to parse it.
Yes, and we have the logic for that, right? So even so for example, in R1, we actually know what the schema is that is actually used. So so this row extension has all this flexibility. You can reference the schema, you can do all of these things.
Yeah, and I guess there isn't any limitation. Configuring a kept function based on a parameter value is possible even in the raw case.
Also in row extension, what you do, the way you do it, Leah. So if you look to row extension, you actually have a schema that you can reference, right?
Yeah.
So for example, if you look to this object, so let's say it's a YANG file. I mean, that's something that I am familiar with. So let's say that the kept function has to render it. What it will do is, of course, that function will be specialized for that thing. It will take the row extension, parse the YANG file, renders it, and does its job. So it's really type safe and all of that stuff. So it's just what this is basically what this extension does in Kubernetes. From my understanding, is that it's basically built for these schema extensions that for which Kubernetes is not really needed to be extended with. And YANG is one of the examples where this is used for. But I see it. So if you look to our example that we have, I see a very similar pattern. That's why I wanted to bring it up, because I don't think it's very well known, or at least from my perspective. But the advantages that you get is the whole dependency management becomes way simpler.
Okay, so if I understand correctly, you're trying to solve the problem that there are not many CRDs you can install, and there is a generic CRD.
So I'm not necessarily. It's a byproduct of it, if you will. You see?
Yeah.
I don't know. Yeah.
It was my trying to understand that what is the problem right now, which we're trying to solve. Is there any?
So let's say, so what is the problem? Let me maybe better understand. Let's say we create a package, right? So we use a package of vendor X. Right? So take the RAM, right? So that means, let's say we basically reference 5 new CRDs as a config ref, right? So starting from this side here, right? That means that someone needs to install all of these 3 CRDs for this particular deployment on the workload cluster. And let's say tomorrow there is another guy who has 5 others, right? We need to install the other 5 somewhere. So with the other approach, what you do is you have this one CRD, which is kind of a meta, right? So it's kind of let's say an encapsulating element. And so whether you have 3 or 5, it's always one. You only have to install one CRD in the workload cluster. So that means that all that dependency management becomes very different, because it's always the same. So you don't even irrespective of whether you have 3 or 5 or 100 or 1 input, the whole system has just one method of doing so.
I think a little modeling goes a very, very, very long way in my book. But would a halfway house be to have a generic Nefio CRD?
Yes, that's what I'm proposing. So if you look what we did, right? So what I'm proposing.
Yeah, well, so I thought this was some sort of one that already exists in Kubernetes. This raw extension, no? Maybe I'm misunderstanding.
So raw extension is a standard API server. So the Kubernetes API server has this capability today. I mean, already for 10 years, I think even longer.
So
okay, I'll let the guys in. I think Fikra and Stephen have.
Yeah, go ahead. I have a question, but go ahead, Fikra.
Sorry, no, just it's interesting to look at. So it's essentially this is dependency management for CRDs. Is there any precedence for it? Like, is there any existing? It's obviously a common problem, is it? Is this not an existing kind of pattern that's been solved in Kubernetes? No.
See, Kubernetes offers you a tool, and then the vendors basically pick whatever the tools are that they believe is suitable for them, right? So I think we have a specific mechanism today, right, that we developed which typically a vendor is not that often developing, right? Because a vendor will say, okay, I put my CRDs that I need, right? I define it myself, and that's it, right? And now in Nefio, we decided so far that we have, on the first place, we have NF deployment as our, let's say, encapsulation for various items, right? Yeah, for the base, yeah. And then we have we said, okay, that's maybe not enough, right? Or not flexible enough. We basically decided so far to use this config reference to give additional configuration for which Nefio not necessarily needs to do anything, right? So that gives us vendor extensions or maybe 3GPP parameters that we don't want to define and stuff like that. So we have this meta concept that we basically built, right? Now, what I'm trying to say is that in that meta concept, the CRDs that are vendor agnostic or Nefio agnostic, if you will, right? We can have 2 ways to go about this, right? And I'm black and white. So one way is that, let's say, you as Ericsson, you basically say, I want these 10 CRDs, and they will have an Ericsson extension, right? That means that we will reference these 10 CRs, right? That uses that CRD in the Ericsson deployment. Let's say Nokia has 10 others, right? So Nokia does 10 additional CRDs, which have nothing to do with Ericsson. They do their own things, right? So that means that there is 10 other CRDs that needs to be done, and then Samsung does the same, and so on and so forth, right? So you'll see already if you have 10 vendors, you already have 100 CRDs that you need to install or manage somehow, right? So with the approach that I'm putting here, by using the raw extension, we would install always one CRD, which is if you use config ref, but we could do something else. But maybe it's 2 CRDs or one or so whether we split between vendor and configuration. But let's for the time being say it's one config CRD, right? So instead of 10 per vendor, you install one, which is always the same, and it would be a Nefio based thing. But within that one, you can have your 10 specific things, right?
Yeah.
You
I
see,
guess
so
no,
that's
it's,
the
yeah,
difference.
kind of
Yeah.
it's kind of classic kind of parent child, or a common base to extend from. Yeah. No, yeah,
But you see that if you have Samsung deployment or Nokia deployment or Ericsson deployment, then Nefio basically installs always the same CRDs, right?
Mhm.
And then it's the operator at the end and maybe a specialization function in between that will then consume that and
extend
do
those.
something with it, right? But it will have to be a specific Nokia or Ericsson or Samsung or whatever vendor that will have to deal with that, right?
The operator would have to extend the common base CRD to make
so
use of it.
the operator at the back, right, has to know, okay, this config reference has this CRD, so the schema that is referred to that CRD has to be understood by the operator, of course, right?
Mhm.
But it stays within the operator or the specialization function, right? If we do that, you see, so the rest of the system doesn't see anything about it.
And then if we put in any generic support for NFs or whatever, that'll all work with them all. Sorry, I jumped the gun there.
Say again, Leon.
Yeah, and if Nefio has some support then for this generic CRDs,
Yes,
or it'll work for everybody's. Yeah.
Correct. So that's the advantages that I see is that it's basically, I call it a meta concept, but maybe the name is not so well chosen, but it allows for Nefio to remain very vendor agnostic, right? While allowing the vendors to do their specific thing. You see? And I think it adds some scalability and it avoids some complexity potential. That's why I wanted to share the thing when I started to build something on the SDK, and then I bumped into this again. So I said, okay, let me share this in the next meeting.
I think the design wise and object oriented and all those things fine, but does it save me some sort of effort, or is it only to the design side, the flexibility side?
It saves you on the installation and the package management and the whole dependency management that are needed to install the operator and build the operator and stuff like that. But the code that sits in the operator itself, I don't see it will change. It's maybe a little bit more. You have to basically parse this config ref and then see what's inside. So that's it's maybe a little bit more, but basically that would be maybe 5 lines of code or something like that. But so the effort on the operator is going to be the same from my perspective. It's very similar.
Like what we use QBuilder to define our to create the
all
controller.
that stay the same. It's just the way you get access to it is a bit different, but it's basically the same.
Yeah, okay. It saves on the number of CLDs that you have to load it on a cluster potentially. But then probably management cluster is much more busy than a workload cluster in this case anyway. And then the second one is it avoids having to do the dependencies of loading the vendor extension CLDs into the workload clusters prior to actually deploying the Neva functions package. So there's some convenience I can see from that.
So if I try to understand that if I have 3 controllers, right, 3 operators, and each of them are working on a different CRs or CRDs, I still have to have 3 extensions, right?
Yeah. Well, vendor per network functions probably has your own extensions, right? Or even per version. So your extension is your freedom. Because you never watched the idea why this probably would work is we don't expect anyone to watch any of the objects point to by config refs. So we originally created config refs on NF deployment because well, because we do believe that we're going to have vendor extensions, and then we want to associate the UPF, SMF, AMF deployment object with all your extensions. So there are a variety of different ways that we have proposed of doing that, and then at the end we kind of settle onto this. So what Vim's proposal probably would take away is if you somehow design something where you want to watch that object for some reason on a separate operator on a workload cluster. Even then you can actually have the object and then still, I guess, massage it into raw bytes and have an object and then point and then do the association and dependencies, because config ref really is there for that reason, just to say there's some way for you to reference back to an object that is associated with this deployment, because Nephew operates on the deployment CL, but then there's always going to be a lot of other things that require for a network function vendors to deploy that network functions in addition to what we define, which is less than minimal, I would say, on the NF deployment the CLD. So in that case, you always have to create other extension pieces for you to deploy it, and all those extension pieces we have to somehow link back to this one thing that the all Nephew NF operator would be watching on, which is XXX deployment objects that we propose. So we do want that. So if that's the intent, that's actually not a bad proposal, because all you have is just a reference. All we need is basically something that point to an object. It doesn't take away from if you still want this to be loaded onto Kubernetes, you can still do it. It's just that we have a unified type over here.
Yeah, but does it take the freedom that someone who doesn't want to go in this generic way will not be able to install the CRDs? No, right? They can still do that.
Well, Vim's proposal is to change the type directly, right? So we no longer have object reference. It's now on config, basically, right? Or raw. Yeah.
No, you still have config refs. So Stephen, you have config refs, so it's always will be this CRD with some namespace.
Okay, so
this will always
remains object reference, right? So the config ref is.
But this API version kind will always be the same. So this will be a Nephew based thing. But
so you're not changing object reference to this particular type, right?
No. So what I'm proposing is that this the content of this. Yeah. So wait, so which freedom is taken away? Say again.
So he was asking whether we're changing the type of config ref to be your new proposed type instead of object reference.
Wait, so it's still object reference at the end?
Yeah,
okay, we can restrict it.
Could be anything.
We at the moment it can be anything, right? But even in this proposal, it's still anything, because basically this is basically referencing the CRD that I showed you, but the content inside of it can be still very vendor specific or whatever specific things. And by doing so, that means that we could restrict, or if you go this way, what you would do is in the operator in the workload, you would restrict it that only this CRD is installed on the cluster, right? But of course, you have the 10 CRs that I was referring to for Nokia, Samsung, and Ericsson would be, so you will have 10 of these in it, and there will be 10 Nokia ones, and
I think the question is if we're not changing the type on the NF deployment directly, but then you still
I would
the config reference is still object reference, but the majority of the cases will use your new thing to embed the type. But then in some vendor specific cases, for whatever reasons, they would like to load their CLDs anyway. And then they would like to create the objects directly on the workload clusters. They can still object reference to their own object on NF.
Yeah. And we can still allow that, by the way, but on the other hand, we can also set a direction. So on the other hand, we could set a direction to the vendors to say, use this approach because here are the advantages.
Definitely make recommendations, and
you see,
and
so we can.
On that,
we don't have to restrict it, but it would. I would put the direction to the vendors or whomever uses the system to say, use a single config reference rather than a vendor specific one, because you don't have to do all this dependency management and stuff like that. So it saves on that side.
Yeah. So it's a recommended way.
Okay.
Yes.
Okay.
Well,
Go ahead, Tom. Sorry.
So I like this a lot, and I'd actually take it a step forward, step even more forward. So first of all, kind of to Stephen's question, I think I would change the name. I would just call it extensions instead of SIG. It could be anything. They could be custom releases, or they can be their own special opaque object here, right? Although I would not call it config, because I think it's just any extension. Config, the word config is very, very overloaded. So I would avoid that word here, but I would call it some sort of like a generic object or something. So it's it's a CR it's a standard CRD part of Nefio, but it can allow any kind of data to be in there. I'm very much for that. I think it's very, very useful, right? I don't know whether it's recommended or not. I think it's kind of up to the deployment, because obviously the advantage of CRDs is that they're structured and schema validated. We don't quite get that here. It's raw data, but sometimes that's what you need, because you're inserting raw data that's not KRM, for example, Yang. So I think this is it could be very useful, I think, for a lot of deployments. I will add, though, that I'm generally a modeling skeptic, right? This whole idea that we are creating UPF deployment, SMF deployment, that we have these standard kinds that everybody will use. Are we seriously going to catalog every kind of network function type in existence? We're not going to be able to do that, and they don't map neatly to what vendors do anyway. Not all vendors divide their CU, for example, into the individual deployment units, right? There might be just an entire CU, and that's what's being deployed, right? Rather than SMF, UPF, et cetera, separately. So I think, to go a step forward even, I would have just a generic NF deployment kind that all it has is extensions, right? It's just
but we can do that. We have that.
Sure.
I mean, we can do that today. Yeah.
Yeah, we can definitely do that. We just didn't do that. We don't have that type. We can do that, right? I'm suggesting
we do.
We do? We do have a deployment type? Okay.
Yes, we have NF deployment type, and you can use it for
so yeah,
basically.
NF, so you that's the extreme case I think we talk about. With the extreme case of saying that, so because what we need is a signal to the operators that we want to deploy a
right. So if I can finish, I was just
so take to the extreme cases. You don't need any parameters, just vendor extensions.
Yeah.
Right, but I just a missing piece there to make it work is that, yeah, operators, the way the Kubernetes API works is that you register by GVK. So obviously, if all the all your functions have the same kind, then you're scanning all of them, but you don't want all of them. So we do need, for that generic kind, to add some sort of name. So when you scan and look for changes, you can actually look for the type that you want, right? Because if they all have the same CRD, right, the same GVK,
I see what you're saying, but
yeah.
But that's the reason, Tal, why we have. If you look to the structure at the moment, we have NF deployment, which is where everything is defined, and we built an SMF, but it uses 100% the NF deployment, right? And the reason why we did it is because I think, for the same reason as you said, is if you deploy an SMF and a UPF and an AMF, right? And they all, so if they all watch NF deployment, they need to somehow be able to distinguish whether it's relevant for me or not, right? So that's why we use the kind as a distinguisher. But if you look to our types underneath, they are all the same. So the reason we just did SMF and AMF and UPF was for, we have three operators, or we actually have three controllers that each look for their specific kinds, because today controller runtime, the only way you can distinguish the watch for the time being is kind or namespace.
It's not just the controller runtime; it's the Kubernetes API limitation.
Yeah, correct. So it's the whole system. Yeah. So basically, namespace on kind is the distinguisher. Anything else, you have to basically do an additional lookup and logic. But everybody will get them.
Right. So
that's why we did
the reason. This is the reason why is because we do the demarcation, I guess, or demuxing at the point of watching. So if we do it at watch a generic thing, and then at the point of parsing the object is when we start routing the different logic, then you can do that. You can even create like Go routines for each of the processor internally. So I mean, watching a generic type is actually something we can is very doable.
Yeah, but
Right,
you will
I
send
don't
it to
think
all the
it's a-
controllers. You
Yeah,
send
you
it to all
basically
the
have to.
controllers.
Yeah, you have to create your own Nephew, controller runtime ish thingy. That basically kind of replicate that logic.
That would be very
Well,
and expensive, by the way. You have to be.
It might be expensive, but also remember it's commensurable with the size of the cluster, right? How many network functions are you deploying on a site? It's not an infinite number, right? So if you're scanning and just ignoring some, yes, there's a little bit of waste, but it's not huge. But the question is, what are the trade-offs, right? The problem here, right, is that we are requiring to install CRDs, right? And if you don't know in advance what you're installing, it does add a lot of complexity. Right.
Sure.
So,
originally we had what you said, Tal, but we changed it to
right.
SMF and AMF and UPF because of the reasons that we said. But is it absolutely needed? No, right? Because what you can do, you can filter in the operator as well, right? I mean, I've done that as well. Is for example, you say you add here, for example, a provider field, right? And so that's what some
you
people do,
filter
like
by
the gate.
label. Yeah.
Yeah,
Actually,
whatever,
a lot
right?
of operators out there do that, right? You register for a GBK, but then you filter and only deal with things. You check some sort of status or something. I mean, generally, that's how the operator pattern works, right? You don't reconcile everything. You pick and choose which you want to reconcile. So this would be part of the logic. Final point I'll make is that the extensions, what you call configurefs here, they might live in that NF deploy, right, rather than here, right? Because if we have extensions on both, it starts to get confusing where to gather them. But
yeah, so how I saw other people use it is parameters ref is another way. We use config refs at some point, but so we have to change. So this is what we did in R1, so we can change it, of course, right? So what I've seen in other projects being used as a reference name is parameter ref. I don't know whether you like that or not.
Yeah, or just
because
object
extension
ref,
is also
the name in Kubernetes API, right? So
so we could. What you're saying, Tal, what I understand, what you're saying is you would advocate that this would become NF deployment, right, instead of SMF, UPF, CU, DU deployment, right? So that's one. And the second thing, what you're basically saying is change this to parameter ref or object ref or something like that, right?
Right.
And then. Yeah, so this can be, we can use the aggregated approach.
We can have some standard extensions, right? Like things like our Multis provider stuff. So there'll be when you install Nephew, the point is Nephew will come with a whole bunch of supported CRDs, right? And the idea is that all of these CRDs have functionality that Nephew provides. So it could be the Multis stuff. It could be these kinds of extensions. It could be NF deployment, right? The idea that you would also have to install vendor-specific CRDs, yes, in some cases you might, but that does add complexity that potentially we could avoid. And but generally, I'm saying that the idea of and I was opposed to this from the start, that we have different kinds per network function type in a general sense. I think this is kind of a losing battle. Are we going to have 50 different deployment for different NF types, and will they really satisfy the requirements for every vendor? And in the future, and if the future there's a new network function type, will somebody have to propose a new kind for Nephew? And what's the difference between these anyway? It's just a string name, because we're not putting any properties there, because we'll never be able to satisfy a UPF design that would fit every vendor anyway. So I kind of feel like this is a losing battle to create these. I think it was fine for R1, where we were just doing free 5GC and really just had 3 network function types, right? UPF, SMF, and AMF, right? But I don't think this is scalable for the future for the project. But I'll say a general comment. In SIG number 1, we wanted to start to centralize modeling discussions there. And the reason is I do think, these modeling discussions starts to get really dispersed, right? So we're having them in work group 4, we're having them in SIG automation, and we're having them in the main SIG1 group. I would like all these modeling ways of thinking and proposals, and to be in a place where everybody who wants to be part of these discussions can be there. Because a lot of this stuff, for example, I was during R1, I have a lot to say about this, but it was really within the specialization group where a lot of these conversations were happening, and there was just not enough
package management. I think none of this was discussed in. It was not in specialization because we just executed, but it was in package management.
Yeah.
I mean, this some of this config ref, this approach was discussed between Stephen and myself. I mean, we shared that approach, right, in the PR and stuff like that. But it was between you and me, basically, Stephen, right?
Yeah, basically. Well, I mean, practically speaking, most of CLD is between you and me. So, oh well.
Yeah, and I'm not complaining about that. We decided as a group to move quickly in R1 and make decisions, but we all agreed that that won't happen forever, right? And I had my own
yeah,
CR
it should not. Yeah, there are folks from SIG1 that ask for information model and stuff like that. We should have them, let them have a say in the matters for sure. I mean, it was kind of rushed to do so.
Yeah. So I guess I'm saying that I like this proposal a lot, and I think it should happen in work group 1 rather than 4. So we're just building that up right now. And Bernard, yeah.
Okay. But so my goal is to discuss this so I think my goal is to discuss it tomorrow in SIG automation as well, right? Because we have this item of vendor extension. So it has so it changes what we did in R1 a little bit, right? So there's a few changes. And my plan was also to discuss it in SIG 1 or work group 1 or whatever on the Monday call.
Right.
Because
but you see my point. It's like starting to give the same presentation 3 times. We should have all these conversations, I think, in one place where everybody who's interested.
Yeah, but you have to. But yes, but okay, you have to. Okay, I mean, it touches the SDK, right? So what I'm seeing is that not everybody is in all the meetings.
Okay.
So you somehow have to figure. That's why I'm unfortunately, unless everybody attends every meeting, I think you have to repeat sometimes a little bit some of these things.
I think this is good discussion, and we have recorded this as well for the future reference. So I think whatever you had to present, I think you presented, right, Wim?
Yeah, I'm done. Yeah, so we done. So, but I think we have to discuss it again in SIG automation. We cannot decide here, in my view, right? So we have to discuss it tomorrow, and then on Monday next week, probably, right?
Okay.
So, okay, let's move on.
I think it makes sense.
Yeah. Fair enough. Then, Stephen, would you like to continue? You have 15 minutes, I think, or maybe 13 minutes for the POC part, right?
Very fast. Here.
You're sharing?
I'm trying to. I have my thing on my nephew account, so it doesn't show up on my sharing until.
Okay. If you want me to share, I can share.
Yeah, no, it's okay.
Okay.
Can you guys see it?
Yes.
So I literally wrote this up like right before the meeting. That's why you saw me share that in the last minute. So sorry about that. So I think we have so many people volunteering for SDK, so I really appreciate that. Thank you very much. And because of this, I don't want folks to just sit there and wondering what's going on. And then we've been talking about having a POC, individual POCs that should go on anyway, in different areas. But then I would like to at some point converge and get them together at one particular use case where a lot of these will be exercised. So one scenario that I could think of would be using the same O35GC because we know it works. Take just one network functions, UPF. So we don't have the complicated extension, which is the SMF. The SMF will require all the UPF to group in. You probably have to involve management clusters and everything to make this happen. But for UPF, there's only one vendor extension, which is basically the image path. And then everything else is simplistic, so we can go with this. So the idea would be, let's start building the nephew SDK and take the pieces that works. And then the backend, instead of writing a full operators, the backend would actually be invoking the Helm charts for 35GC UPF. So how does it work? Well, first, the SDK, like any of the SDK, gives you a workspace. So you create that workspace, you tell them you're using Helm, you're pointing. So these are all what Fiacre is working on right now, which is the operator, trying out the operator SDK, the Red Hat operator SDK, and see how that integrates with the Nephew SDK tool chains. So that's a pretty major piece of this POC, which is to take the. I'm guessing Tao's hand is stale.
Yeah, but there's someone.
Yeah. So but Liam's hand is new. So if you have a very quick question, go ahead.
No, I was going to come in at the end, but I just wanted to say we've been working with the Fiacre's been working and with the
So this is unchanged. So we get this, the same operations. You're pointing to a chart directory or a package, a bundle, a tar zip file, and then you'll take the values.yaml and create a CLD.
Okay, no, carry on.
Okay, so the next thing would be, let's say this is UPF. So there are two options as I talked about on the areas documents or task list documents. That one of them is someone who wants to write the full bloom operator. So we'll create a reconcilers. We'll even provide them with a library. So Denny's from VMware wrote some libraries that are parsing the NF deployment basically pieces. We can make that much more elaborate and then go with this. I think this isn't as impressive. It's nice to have it. It would be great to do both options even, but then it's not as impressive is a strong one. It's not as interesting because we know this works, and then you have to do it in Golang. So you don't necessarily see it as if you present it to an NF vendor, you don't necessarily see a lot of savings per se, other than you can use Helm charts now, which is maybe it's interesting, but then not as much. So I would propose let's go with like the second option. The second option, as we talked about, is I name it Proxy, which I think Tao has a problem with. But then any of the Proxy options, the Proxy option is we write a default operators that would be watching a particular object that you point to. So in this case, if your error type is equals to UPF, it'll be watching UPF deployment. Will be, and you can just specify programming language. So because internally, right now the thinking is internally use gRPC to send a gRPC message to this gRPC server that will generate. So we generate a Python gRPC server, and then they have to write the developers or the NF vendor, FreeFileGC NF vendor in this case would only have to write that Python piece where so either case you do one thing. The code logic does one thing only, which is to take the Nephew specific CL UPF deployment in this case, and your extension CL, which for FreeFileGC is very light, combine them and then basically come up with the CL for values.yaml, the corresponding CL for CLD for values.yaml for your custom resource instance for this one particular deployment. Make sure that you take the combination of the Nephew and vendor extension CL and create and generates the values.yaml CL. So we can even have a callback functions where all you have to do is fill up that structure and then ship the structure back to the proxy, and then the proxy would then take that, format that into the CL, and then apply that onto Kubernetes API server on workload cluster. So that's the thinking of the direction. So what would happen here on the user experience is you are creating the workspace. You would take advantage of the operator SDK pieces that creates the CLD for your values.yaml. And then you also manually creates a CLD for your vendor extensions. By default, because you're telling us you're using UPF, in the future you probably have to tell us which particular Nephew API versions you're using. It will also be generating that CL in the package. So at the end, the most important thing after all of this was obviously after you do the code, you have to build it as a Docker image and push it in somewhere in Docker Hub or some other hub, and then that becomes your image path. Update that on your deployment. So that's your operator, and then it generates. So the tools will generate at least two packages. Well, exactly two packages. One is the operator package. So what you just did is basically like an extension of the operator. So you're extending your FreeFileGC knowledge and somehow plug it in to a default operators. So you have a vendor operators created. I mean, internally how it works, it doesn't matter, but that's basically the feeling that we want to present to NF vendors, that they're writing this simple functions. And then it kind of plugs in and becomes an operator. But then they don't have to even know anything about the how to do Kubernetes, or if they hate Golang, they don't have to write Golang. And then, so the other additional things that we have to do before you generate a package is you have to see all the spelling problems there. You have to then create a compatibility specifications. So at the very least, there are three things involved. There's whatever is running on FEO, the management cluster right now, or whatever that's been deployed. The second thing is your operator version, and then the third thing is your NF package version, NF version that is pertaining for that particular deployment package. So we want you to list what those things are in terms of compatibilities. On this is the metadata things that I talked about on the task list. So embed somehow on the SDK, we want people to be able to specify what they want to add in terms of compatibility informations, and then we'll embed that into the NF package and the operator package. And then so we generate both of those packages. And then the magic is you load those packages, you specialized, maybe manually on the POC. And then magic happens on the workload clusters where the 3.5GC UPF would be just running. So these are, if you have time to read it, this is basically the steps that I kind of point to. So go ahead, Sandeep.
Yeah, this is regarding the operator part. Okay, so what do we get what kind of control do we get in operator, like the controller, the NF operator, where we can take some sort of action?
So if you have additional logic beyond just this on the gRPC server, I mean, let's say tentatively say gRPC server. The gRPC server is a running pod. So you basically create something that looks like a controller. Or you can link the gRPC server if you write your own controller, for example. If you write your own controller. So what the motivation behind the proxy server, the proxy operators, I do it on an actual real use case, is that we work with a vendor that has its own operator. And then and it's, to be honest, much better built operators than the one we wrote. Not here, but no, on our own setting even. And it's much more elaborate. So what it does is it takes something that looks like a Nefio CL, and then the extension pieces that is needed to configure their 5G core, and then we extract the fields from the extensions and the CL, let's say Nefio CL, and then push it into the CLD, the CL for the vendor, and then we apply that CL directly inside. So the motivation behind this is simple. The logic is always the same. The logic is almost always taking Nefio CL informations plus the vendor extension CL informations and generates a structure that is needed for you to apply and or configure your own network function vendors in order for you to deploy it. So you have full control over what kind of CL you want to create. You can create your own operators on the back end, in which case the proxy will apply your vendor specific CLs to the workload clusters, so that your operators would be waking up out of monitoring, of watching, and then process that CL. And in this particular POC obviously is Helm. So all you have to do is translate into the input for Helm, and then apply that through Helm operators. So as a POC, I think that touches almost every single little things that we've done, except for developing an operator piece, which is important, but it has to be there. But then the POC is trying to see, I mean, again, minimizing work from the end vendors.
I still have to write the own, if I really want to take advantage of operators and all those controllers, then I have to write everything again from the beginning, or will
Yeah, so if you really love to write your own operator,
I don't
obviously
want to
just write your operator from scratch is also fine. But then if you want to take advantage of the SDK, the option would be more like this option one, in which case you write it gives you a reconciler on a Nephew CL, and then after that, the rest of the logic is yours. So you can write complicated operator logic inside, and you because you're part of the operator, you're just writing on top of the reconciler. So you have the client handle for Kubernetes API server if you want to use it, and whatever things that you need in terms of making REST API and so on into your own backends. So you can take that options if you want to write a full bloom operators that watches Nephew, but then it fully implements a vendor logic. So that option is always there through the SDK.
Yeah. Okay.
Wim?
I have two questions. One is, what is the value of the gRPC server?
Language, because I'm going to write the proxy is written in Golang, so instead of link a library into the proxy, the gRPC allows us to link to something that's written in a different language.
So here is my question, right? Because you said you will expose the CRD from one operator to the other, right? So why just not put the first one applies it to the API server, and the second one picks it up from there? And if they want to implement the controller in Python or Rust or whatever they want, they can do so. So because right now, so in other words, the advantage of that approach is that you don't have to change anything to the operator of the vendor. They can use as is, and you just so you basically, the first thing is basically a pre-processing for Nephew to a values file, and it will. So I'm questioning what is my first question is the real value of the gRPC server.
So I guess when I gave you that example, it kind of confuses people. So the major advantage really is the fact that for folks that do not want to write an operator at all, they want to come on board.
Yeah, but I think you said that the reason to do so is that there is an existing operator already existing.
The initial reasons when I built the proxy was because the vendor that we work with has their own operators. So we basically proxy through, let's say, Nephew CL, and plus they run the extensions and be able to generate their CLs into their operators. So that's the easiest way to get a POC going. But then to use the same mechanism, you would be able to address to those vendors where they don't have an operator, but then they understand how to take some structures and translate that structure into a values.yaml type input. And then so they only have to write that piece of code in whatever language they want. And then we generate stubs out of the gRPC servers, and they only have to implement that and just send us back the structure.
But why don't we allow them to just extend the operator SDK with that function, and that's it? So you don't. So what I'm saying is we add a lot of complexity for very little value. Is what I'm trying to say.
Yeah, but then if that's the case, our proxy would have to be written in a variety of different languages then, right?
Okay, I'll show you an example. I'll in my POC I will address this, but okay, I have a different approach on how to solve it. The second question I had was regarding the compatibility list. Is can you explain what you're trying to achieve?
So there's something running. So the idea is Nephew is running. Someone is going to load a package that says this is operator. This operator is. I'm going to deploy this operator, and then we have to somehow be able to mark that this operator is watching a particular CLD. It's the definition of the CL they're watching matches whatever is generated from Nephew, the Nephew that's running right now on management cluster.
Okay, so that was, I thought this was out of
so
scope.
I don't think we have something like that in our one. So I'm just saying that we have to solve the problem as part of this SDK. So yes, it should be generically solved by either Porch or some other on Nephew system. But then
did we not say that this was out of scope? Did we not say that this was out of scope?
This is something that SDK depends on. So I asked if someone from the SDK team would be taking on it, probably in the context of SIG 2. But then we need it basically. So in the same way as we need it, and then we also need to agree on the CLD where we'll embed as more of our software metadata, if you will, that will be embedded inside the package that we generate as part of the SDK. So the SDK needs to generate a package that has this information inside the package, or maybe just annotate a version. And then, but then it's probably more flexible if you want.
And why are we not just using? Why are we not just using the API server logic that we already have?
The API server logic. What is the API server logic that we already have?
Like there is version inside. What I'm trying to get to is what is the version doing that is not there in the API versions of the CRDs. Why do we need an additional mechanism that is, because today the way that you basically model or express version things is on one end through the API server, and the second thing is through the image that you use for your operator, right? So these are the two mechanisms. So I'm questioning, why do we need yet another thing? What is the value? Because we are going to introduce a lot of new stuff, and the question is, what problem are we trying to solve that we cannot address with the mechanism we have already today? And not today, I mean in the Kubernetes ecosystem is what I'm saying.
Yeah, but then who is going to cross-check which version of the operator from a network functions actually works with a particular network functions?
I wonder, could I jump in, guys?
That does not even exist today. So this is outside of the scope of API server and outside.
That's our dependency. Is that not our dependency controller?
This could be, but then where do we express that?
I mean, that's for me part of the requirements.
To express that, and then my point is the best way to express that is to expect that is to embed that information inside a package, and then that becomes a. Again, I don't have to write I don't want to write the controller, but then I do think that information is embedded inside a package.
Yes, but that's going back to the thing that we are trying to address with the software. But in my view, we are trying to solve this with our dependency controller that we are trying to start scoping in NF2 infra thing. So I think we have to do that before we can do it in the SDK. I thought that was what we agreed in when we discussed it at some point, but we are running out of time. But we have to discuss this further, I think.
Sorry, guys.
Liam.
Yeah, I have some comments I want to make, which I won't be able to cover in 30 seconds. So maybe could we park this and we can go back next week?
Yeah.
And also FICRA has some findings on working with the Helm operator SDK, and actually it's mainly around how that integrates and how the Helm stuff integrates back into the infra, which I think is interesting to Henrik. So I think maybe we should get that input from FICRA and then carry on the discussion, because I think one of the biggest issues here is how do you get the existing Helm world to link into what we're trying to do in FIO as regard infrastructure. And look, if it's okay, I have to soon go as well, because it's would that be okay if we park it or even have another discussion some other day?
I think we have to continue this in next meeting for sure. A lot of questions I also have, but I don't take time, so we'll continue this in next meeting for sure.
Okay.
Yeah. Thank you.
Okay. Thank you.
Okay. Thank you, Steven. Thank you, Wim. Thank you, everyone.
Thank you. Bye-bye.